Welcome back for homework for 724. Today's homework's a little bit longer, so hang on in there. Not quite as short as the past two. So for the first one, we are just comparing our slopes here, and we're asked if they are greater than, less than, or equal to each other. So in order to compare fractions, we know that we need to find a common denominator. So since 6 doesn't go into 7, we can find a common denominator just by multiplying them. So 6/7, I know 42, right, because 6 times 7 is 42, will go into that. So what did I do? I multiplied by 6, so I have to multiply by 6 here as well. 6 times 6, we know, is 36. So these are equivalent fractions. I have to do the same thing with my 5/6 over here. Again, we're converting it to 42s, and I had to multiply by 7 here, so I have to do the same thing on the top, which is 35. And when I do, now I can compare these, right? I can easily see that this fraction is larger. Okay, so I would say that if I wanted to compare these, that 6/7 is larger than 5/6. Okay, next one. This one works out well because 2 goes into 10 nicely, so we only have to convert one fraction. This 3/2. All right, converting it into 10, we have to multiply by 5, so we have to do that on the top as well, which would be 15. And then I can compare them, and actually they end up being equal, which is kind of nice. So these two fractions would be equal to each other. All right, next one was another nice one because I only have to convert one, right? 5 goes nicely into 10. So I only have to convert my 7/5 into, oopsies, that needs to go as the denominator, as a 10 as a denominator. So I multiplied by 2. Doing that on the top, we would get 14. And then I can compare that to 12/10. We can see that this guy is larger, so we can compare and say that 7/5 would be larger than 12/10. All right, hopefully that makes sense. Not too hard. For the next one, we have to describe the associations between the graphs below. Remember to describe them, the form, the direction, and the outliers. So the first one, we can see that this is definitely trending upwards, right? So this would be a positive association. It is not linear though, because if we were to kind of draw in that line of best fit, we can see how it kind of makes that U. So it is non-linear. It's kind of a parabola. Non-linear. It's not straight line. And are there any outliers that are way off? Not really, right? There aren't any way over here or, that are really sticking out. So we could count this guy right here as an outlier, I suppose. We could say with one outlier or with none. Either way, with one outlier. If we said that this guy was part of the trend, he's not too far away either, but for the purposes of this, we can say with one outlier. All right, graph 2, again, trending in a positive direction, right? Positive. And then this one is kind of linear. I kind of drew in my line of best fit right in here. It does form that nice straight line for the most part, linear. And this one really doesn't have outliers. I could draw my line generally through most of the points, and there's not anything like goofy in this corner or this corner. So we'll call that no outlier. All right. So those are associations. Flipping it on over, it is going to tell us that Ella and her study team is arguing about the slope of this line at the right, and they came up with 4 different answers. Wow, there's a whole bunch of different ones here. Which slope is correct? And then we have to justify. So to do this, we're going to try and find some points that are right on the line. So I can see right here's one. There's one. It looks like, wait, is that here? I think so. It looks like 1, 2. Okay, and then I'm going to draw my growth triangle. And I can see I'm going up 3, right? 1, 2, 3, and over 1, 2, 3, 4. So, and then my graph is sloping downwards, which means that I'm going to have that negative slope. So the slope would equal negative 3/4. So really, this person right here would be correct. The line is decreasing. So that means we can automatically like cancel out both of those two. And for every 4 units across, we're going 3 units down, right? That's what that over, down means. Okay. All right, next up, we have to solve the following equations. Wow, this problem is set up perfectly for Fraction Buster. So we're going to multiply by each of these denominators, a 6, a 3, and a 4. So we're just going to write those up top next to each number. Oops, 6, 3, 4, 6, 3, 4, 6, 6, 3, 4. Somehow get them all in there. And then we're going to go through and we're going to cross cancel. We're going to look at our denominators and say, is that the same as any number? Yes, the 6's will cancel out there. We don't look at the numerator for this at all. It's only the denominator. So then we do the same thing. 3's can cancel. 4's can cancel. 3's can cancel. Basically, a 3 divided by 3 is a 1, so that's why we can get rid of it. Then we need to go through and multiply whatever we have left with the numerator. So 3 times 4 times 1 would be 12x. See how now my fraction is gone? It works out really well that way. All right, 6 times 4 times 2. So 6 times 4 is 24. 24 times 2 is 48. So plus 48 equals 6 times 3 is 18 times 1 is still 18x. Minus 6 times 4 is 24, times 1 is still 24. So now my fractions are all gone. Now I can just solve for my x's. So I'm going to start by moving these these 12 over to this side by subtracting. Which leaves me with just 48 on that side. When we subtract here, we should get 6x minus 24. I'm going to move the 24 over before I do anything with those x's. So then when we put these together, let's see, I'm getting 72. Okay. And then, did I do that right? Yeah. Okay, equals 6x, right? Then we would go ahead and divide by 6 on either side, and we would get x equals 12. Okay, very good. Okay, for our next piece, let's see, we can just distribute everything inside of our parentheses. So that means we have 0.15w plus when we multiply our 0.15 times our 2, right? Then we get 0.3 equals 0.3 plus 0.2w. Oops, here, let me move this up some so that you can actually see. That might help. And then I'm going to subtract my 0.3 on either side, right? Again, combining my terms here. So I have 0.15w equals 0.2w. And then I can go ahead and subtract. So let's just subtract the 0.5w minus 0.15w. So I have 0 equals, what would I have here? Let's see, 0.05, right? W dividing to get the w by itself, which means this is still 0 equals w. All right, there we go. Whole lot of work to show that it equals 0. All right, and then for my last one right here, on this page anyways, I'm going to multiply my 8x times my 54, and I get 432x. And then my 6 times my 72 is 432. I'm going to divide to get my x's alone, and x equals 1. Those numbers looked really big, but it just boiled down to 1. Nothing too bad. All right, flip it over. Oh, we have one more. Okay, so here again, we're going to distribute. So we have 6x minus 7 times 3 is 21. Just rewrite the rest of your problem. Actually, I'm going to do like 2 steps in one. I'm going to rewrite and combine the 5x and the x to get 6x plus 17. Okay, and then I can subtract my 6x on either side to move them together, and actually it makes 0 pair on both sides. So I just have negative 21 equals 17, which guess what? That is not true, so we can write that as a no solution, or no sol. All right. Number 75, we have Salami and More Deli sells a 6-foot sandwich for parties. It weighs about 8 pounds. Assume that the weight per foot is constant, so it's growing by the same amount. How much does the sandwich, how much does a sandwich 0 feet long weigh? Well, first of all, if you don't have a sandwich, right, if it's 0 feet long, how much is it going to weigh? It's going to weigh 0 pounds, right? If you have nothing, it's going to weigh nothing. Okay, that was kind of a little easy one for us, I guess. Next one, we're going to draw a graph showing the weight of the sandwich on our vertical axis and compare the length of the sandwich on the horizontal. So I'm just going to pull out my pen here and draw us a x-axis and a y-axis here. Sorry, that was not very straight. Okay, so this is the length, and it's measured in feet. This is my weight, measured in pounds. Okay. There we go. All right. So, all right, so we drew the graph, the weight of the sandwich. Okay, so we have a 6-foot party sandwich, and it weighs 8 pounds. So if it's, I'm just going to label these by 1. So 1, 2, 3, 4, 5, 6. And then it weighs 8 pounds. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. So there's our first point, right? If we assume that the weights are consistent, then we can use our graph to estimate. Oh, and we know that if it's 0 feet long, then it weighs 0. So I can just kind of extend my graph here by connecting my points. Let's see. Actually, I'm going to use this side, sorry, of my Gorilla Glue packaging. Who knew that would come in so much handy for doing your math? All right, there we go. Oop, just sent the Gorilla Glue flying across the floor. That's fun. Okay, so we can kind of see our growth triangle right here, right? If we're going up 1, 2, 3, 4, 5, 6, 7, 8, remember? We're coming across 6. That is our slope, essentially. So if we want to know how much a 1-foot long sandwich would be, right, we would just kind of bring it up to right here, and we can see that it's a little bit above that 1 mark. So that means that y equals 4/3 pounds. Okay, that's about where that's going to hit, just slightly above that 1. There, sorry. Write a proportion to find the length of a 12-foot sandwich. Okay, so if we know that a 3-foot sandwich, if we know that our slope here, right, when we simplified is 3/4, because we divided 6 in half and divided 8 in half, that would be equal to that 12-pound sandwich. We can then cross multiply. 4x equals 36, dividing by 4 on both sides. We would get that x equals 9 feet. So that's about how long a 9-pound or a 12-pound sandwich should be. Okay, flipping it over, we have a little bit left on the back side here. Perfect. All right, so we just have some area problems. We have to find the area for the rectangle, and we have to show our work. So for this one, it's pretty easy. Length times width. So we're just punching in on our calculator, 48 times 102. And in this case, we get 4,896. And it's in units squared. Don't forget about that square when we're finding the area of something. Okay. For this next one, it's nice. It kind of breaks it apart for us. So we have to multiply our length times our width for just this first little rectangle. So 13 times x would be 13x. And then 13 times 7 is 91. So the way that we would record this would be 91 plus, right, to find the area of the whole thing. It would be 91 plus 13x, and then units squared. So just like before, we can't combine our x's and our units. We just keep those separate, and we just write it out like a little equation. Okay, next one. 32 times 20, plugging that in on our calculator, is 640. And then 13 times 20 is 260. We can then go ahead and add these together. So 640 plus 260 equals 900 units squared. Okay. And then for our last one, we just have to do these 4 boxes. So 9 times 11 is 99. 11 times 15 is 165. 9 times 3 we know is 27, and 3 times 15 is 45. Then we're just going to, again, add these up. There aren't any units there, so we can just add them. Equals 336 units squared. Okay. Pretty straightforward, hopefully. All right, well, thank you for watching. Come on back tomorrow.